Hello students and welcome back to my channel. Good evening. In this video we will be discussing questions based on modern physics which were asked on the 29th of January 2024 JEE mains. So without wasting time, let us move to the next question. So this question is in continuation with the previous questions. Okay. So this is question number 5. Here we go. The de Broglie wavelength of an electron is the same as that of proton. So the de Broglie wavelength of electron is same as proton. So as we know students, that de Broglie wavelength is h by p. So if lambda is same, that means p is also same for both. So this is the first condition we are getting. The momentum of electron as well as photon is same. Then if the velocity of electron is 25% of the velocity of light, then the ratio of kinetic energy of electron and energy of photon will be. So it is given that electron velocity is 25% that of velocity of light. The ratio of kinetic energy of electron and energy of photon. Now students, we will use this simple formula. Remember, electron is a particle and photon is a photon, of course. So there is a slight difference between them. Now energy of electron will be half mass of electron into velocity of electron square. Okay students. Here I can write this as half mass of electron into V of electron into V of electron, which can be written as half momentum of electron into velocity of electron. And this velocity of electron is given as 25% of c, where c is the speed of light. Then coming to energy of photon is simply p into c. Okay students. So from this we can obtain energy of electron to energy of photon is equal to 1:8. You can see students, because p c gets cancelled, we are left with 1:8. So correct option will go with the correct option, second option. Then moving to the next question. The explosive in a hydrogen bomb is a mixture of this deuterium, tritium and lithium in some condensed form. The chain reactions given by this. During the explosion, the energy released is approximately. Now as you know students, this is a question based on nuclear fission. Okay. So what will be the case, whether it is a case of nuclear fission or fusion? We all know that nuclear energy is usually released at the cost of mass. So when certain mass disappears, an equivalent amount of energy is released, which is known as nuclear energy. Okay students. So here also same thing we'll do. If we add these two equations, then we'll get what we'll get is this. This will get cancelled, tritium, and neutron will also get cancelled. And finally we are left with this plus this is equal to twice of helium. So naturally the mass of the reactant should be more than the mass of products. Only then there will be a mass defect. Once you calculate the mass defect in AMU, multiply with this figure, you will get the answer in million electron volt energy released. So first step will be to determine the mass defect. So mass defect will be mass of reactants minus mass of products. So which is mass of lithium and deuterium and mass of product is twice mass of helium. Okay students. So mass of lithium is this and mass of deuterium is this. So if we add, okay, then these two will give you 8.0. 0 plus 1 is 1, 9 plus 7 is 8, carry 1, 5 plus 6 is 11, minus twice of mass of helium. Mass of helium is this. If you double it, it will be 8 to the 16, 6 carry 1, again 8 to the 16, 7 carry 1, 2 3 the 6, 6 plus 1 is 7, and 0 0. Okay students, then when you subtract this, you will be having 0.0. Okay. So 11 minus 6 is 5, 7 minus 7 is 0, then 11 minus 7 is 4. This much AMU is the mass defect, students. Now we know the energy released corresponding to 1 AMU is this. So the energy released corresponding to this much AMU will be energy released. Energy released will be, this is, you can see, 0.240, sorry, 0.024 something into 931.5 million electron volt. So this is approximately 1000 student. So if you multiply by 1000, you get 24. But since actually it is less than 1000, so it should be less than 24. Close to 24, we have only one option, that is 22. Less than 24 and close to 24, we have this. So that's how you are supposed to calculate this. Then moving on to the next question, question 52. You can see two sources emit light with power of this much. The ratio of number of photons of visible light emitted by each source having wavelength this and this will be. Now the ratio of number of photons, okay, of visible light emitted per second, it should be actually. That then only then it makes some sense. So emitted per unit time. Now as you know, the power is same, right? So we can write power is equal to number of photons emitted per unit time into energy of each photon. Number of photons emitted per unit time, energy of each photon is, since we have been given informed regarding the lambda, so we can write h c by lambda. So remember, this is same for both. So I can write n is proportional to lambda. In other words, the number of photons emitted per second for the first and for the second is 300 is to 500. So 3 is to 5 is the answer. Okay students, then moving on to the next question. Given below are two statements. I'll just, what happened? Given below are two statements. Most of the mass of the atom and all its positive charges are concentrated in a tiny nucleus, and the electrons revolve around the Rutherford's model. Revolve around it. So this is true, correct? Isn't it, students? Most of the mass of the atom and all its positive charges are concentrated in a tiny nucleus. This is true, and the electrons revolve around it. This is absolutely in Rutherford model. Coming to statement 2, an atom is a spherical cloud of positive charges with electrons embedded in it. It's a special case of Rutherford's model. This is wrong, students, because actually it should be Thomson's model. The statement what they are given corresponds to Thomson's model. So this is false. So statement 1 is true, but 2 is false. We'll go with the third option. Then moving to section B. when a hydrogen atom going from n equal to 2 to n equal to 1 emits a photon, its recoil speed is x by 5 meters per second, where x equal. Now here students, we have to understand that initially the hydrogen atom is at rest. Now as soon as it comes back to ground state from excited state, from n equal to 2, that is excited state, to n equal to 1 ground state, it will emit a photon. So if photon comes out with a momentum p, the residual hydrogen atom will also come out with the same momentum, because initial momentum is 0. So final momentum has to be 0. So two vectors can be 0 only if they are equal and opposite. So this way you have momentum of both, that is hydrogen atom, residual hydrogen atom, and the photon must be same, of course equal in magnitude only, not in direction. Okay student? Then now in this case we can see that to what extent what is the energy of the photon released, because if we require speed, we should know the momentum. Once we know the momentum, we can calculate the speed, because we know the mass of hydrogen atom. So we have to calculate the momentum. Now as we know, momentum is equal to h by c, e by c, sorry. Okay students? So what is the energy released when a photon jumps from n equal to 2 to n equal to 1? That we'll see right now. So this will be 13.6 electron volt into 1 by 1 square minus 1 by 2 square. This is the energy released. Okay, you divide by c. So we have 1 upon 3 into 10 power 8 meters per second. 13.6 electron volt to be converted into what we call joule by multiplying by electronic charge, and this will be 3 by 4. Okay students? So the momentum of hydrogen is also same. So momentum of hydrogen will be mass of hydrogen, that is 1.6 into 10 to the power minus 27 kg into B. That's what we have to find. B we have to find. So here 1.6 gets cancelled both sides, 3 gets cancelled here. Okay students? Then when it comes this side, we have 27. I think the power of 10 will also get cancelled completely, because 10 power minus 27 comes this side, because plus 27, 7 minus 20, 27 minus 19 is 8, 8 got cancelled. So finally we have V is equal to 13.6 upon 4. Okay students, so this should be equated to x by 5 as per the question. We require x. So therefore we have x is equal to 13.6 into 5 upon 4. Okay students. So this comes out to be approximately 17. Yes, this is approximately. Exactly it is 17. You can just calculate this. So we have 17 as the answer. Moving on to the next question. Question 55. Hydrogen atom is bombarded with electrons accelerated to a potential difference of V, which causes excitation of hydrogen atoms. If the experiment is performed at T equal to 0 Kelvin, the minimum potential difference needed to observe any Balmer series lines in the emission spectrum will be. Now, as you know, students, you get Balmer series only when electron jumps from n equal to more than 3 to n equal to 2. So when an electron jumps from any orbit more than 2, it could be 3, 4, 5, etc. Only then, and it lands up at n equal to 2, only then you get Balmer series. So that means if you want to have minimum potential difference, then at least we should ensure that the electron jumps to the n equal to third orbit, so that from there it will come back to n equal to 2. So minimum energy required will be this. So minimum potential difference will be required corresponding to that. So for that we are asked about this. So what will be this minimum energy required? That should be the energy of the electrons, and electrons should be accelerated through that potential difference. So now let us find this energy here. So difference in energy is 13.6 electron volt into 1 by 1 minus 1 by 3 square, that is 8. So 13.6 into 8 by 9 electron volt. Okay students, so this will be 13.6 into 8 is around 108.8. So this is approximately 12.08 or 09, I should write. Okay students, so this is around 12.1. So that means the minimum potential required for an electron is 12.1 volt. Because as you know, if a charge E, that is electronic charge, is accelerated through a potential V, the energy gained is EV. So if the energy gained is 12.1 electron volt, it should be accelerated through 12.1 volt. Okay. So if you equate this to alpha by 10, so alpha will be 121. So 121. Right students? That's all students in this video. Thank you so much for watching my channel. Kindly subscribe to my channel and hit the like button.